Hello, everybody. Today we're going to take a look at solving systems of nonlinear equations. So nonlinear equations could be lots of different types of curves. So we have things like parabolas, circles, ellipses, exponential functions, hyperbolas. We have lots of different types of nonlinear equations that we can use, and most of them can be solved graphically if you are able to graph them on your calculator or using something like Desmos, and many of them can also be solved algebraically. So we're going to take a look at solving some systems algebraically, and we can use a couple of the methods that you used in algebra when we were solving systems of linear equations. Two of the methods that we used a lot were the substitution method and the elimination method. Okay, and many of the problems can be solved using both of those. You can use one or the other and get the answer, whereas some, maybe only one of those two methods will work. So before we solve this system, let's try to make a prediction and decide how many solutions we think it's going to have. And so we can do that by recognizing what the graphs are. So the first graph, if I get y by itself here, this would be y equals x squared. So that's just a normal parabola like this. And then the second equation is a line. It has a y-intercept of -2 and a slope of 1. So we'd go up 1 over 1, up 1 over 1, and so on. And that looks like that. So from my quick sketch, it looks like these curves do not intersect. So I'm going to make a prediction that there's going to be no solution. And so then we can confirm that algebraically. I'll show you how you could use the substitution method or the elimination method for this problem. For the substitution method, we need one of the variables by itself, which we already have. We have y is equal to the expression x minus 2. So that means in the other equation, whenever I see a y, I can replace it with x minus 2. So then this equation becomes x squared minus x minus 2 equals 0. And that is x squared minus x plus 2 equals 0. Now we can try factoring this, x, 1, 2, but then to get a minus in the middle term, we would need -2 and +1. But the problem with that is now we get, when we multiply these last terms, we get -1, and we're trying to get a +1. So it looks like it's not factorable. So let's, since it's not factorable, let's consider the quadratic formula. So x would equal the opposite of b, which is +1, plus or minus the square root of b squared minus 4 times a times c over 2a. And notice that the discriminant, the part under the radical, is negative. So this would be the square root of -7. So we see there are no real solutions. Okay. Using the elimination method, we could have gotten the same result. That would look like this. If I take the equation x squared minus y equals 0 and rewrite the second equation as -x plus y equals -2. If I add these equations, the y's are going to be eliminated. So that's how the elimination method works. Anytime you have part of the expression, part of the equations that will eliminate one of the variables, then the elimination method will work. So when I add these, that becomes 0, so the y's are eliminated. When I add these, I get x squared minus x equals, on the right side, -2. So then x squared minus x plus 2 equals 0. It's the same equation we got up here. So of course it's going to have the same solution, which is 1 plus and minus the square root of -7 over 2. No solution. Okay, so that problem could have been solved either way, by using substitution or by elimination. Let's take a look at the next example. In this one, we can make a prediction. Our first curve is a circle with a radius of 2 centered at the origin. So that would look something like that. And then the second equation, if I solve for y, would be y equals x squared minus 4. So that's a parabola that is down 4. And so it looks like we could potentially have 4 solutions. It's possible that the parabola could go wide and have no solutions, or just barely touch and have only 2 solutions. Okay, but we need to recognize that those are our scenarios. I'm going to predict that there are going to be 4 solutions. Okay, so looking at our system, I think even though substitution will work, I think elimination is going to be the natural way to do it, because I can get rid of these if I subtract these 2 equations. So I'm going to have x squared plus y squared equals 4, and then negative x squared plus y equals negative 4. So I just multiplied the bottom equation by negative 1 so that I can add these. The x's are eliminated because one is positive x squared and one is negative x squared. Now here when I add these, I get y squared plus y equals 0. So factor out the y, and we get y equals 0, or y equals negative 1. And so those correspond to y being 0 or y being negative 1. So to find the x coordinate, we want to plug those back into either of these equations. So for example, if I plug in here, if I plug in y equals 0, I get x squared equals 4. So that has 2 solutions, plus and minus 2. So that means it could be positive 2, 0 or negative 2, 0. And then when I plug in negative 1, again into this equation, for y, that would be x squared plus 1 equals 4. So x squared equals 3, and x equals plus and minus root 3. So we get root 3 negative 1 and negative root 3 negative 1. So there are our 4 solutions. And again, we could check those in Desmos. X squared plus y squared equals 4. There's our circle. And then this one was x squared minus y equals 4. And we see the 4 solutions that we got. Okay, in this last example, these are not curves that we really recognize. I see the second one, this is actually, could just be a line if I divide both sides by x. But the first one, I don't really recognize what kind of curve that is, probably some kind of a hyperbola because of the xy. But we can solve this algebraically by using the elimination method or by substituting in place of the expression xy. So go ahead and pause your video, give this one a try, see if you can solve this algebraically, and then press play when you're ready to check the solution. Okay, so in this expression here, I can divide both sides by 2 and get xy is equal to x divided by 2. And so then I can substitute this expression in place of xy, because that's what xy is equal to. So then this equation here becomes x squared plus x over 2 equals 4, which is x squared, if I multiply everything by 2, becomes 2x squared plus x minus 4 equals 0, or actually minus 8 equals 0, because I had to multiply everything by 2. And so now I have an equation that I can solve. We could try solving it by factoring, or I'm just going to go right to the quadratic formula because of the 2 in front. and that will give us x equals -1 plus or minus the square root of b squared minus 4 times a times c over 2a. And so that's going to be 1 plus and minus the square root of 65 over 4. And so that gives us two possible x values. 1 plus the square root of 65 over 4, and 1 minus the square root of 65. -1 in both of those over 4. And to get the matching y value, the easiest place to substitute it in is here, because I can then say y is equal to x divided by 2x, and so that's y equals 1/2. And so in both cases, I get y equals 1/2. And so those are my two solutions. Again, I can check those in Desmos. X squared plus xy equals 4. And x equals 2xy. And those are our two solutions. So this number 1.766.5, I'll bet that's this number is probably about 1.766. So if we plug that into a calculator, -1 plus the square root of 65 divided by 4, yeah, that is about 1.766. And that matches what we see in our Desmos graph when we hover over this point, 1.766.5. This one is -2.266.5, which I'm sure matches this. Okay, and that's it for today's lesson. Have a great day.